habit I would develop is you kind of have to, I would say this, like, develop the habit of you read a problem slow and careful, but you're kind of, I don't know, you zoom in and you zoom out. Like, for example, I don't ever read an equation and get fixated on the equation itself. I just say, hey, there's a graph, there's an equation. I don't even worry about the details yet. But it says the graph has a horizontal asymptote at y equal 2. As soon as I read that, my brain recalls a memory. And that's the value of the flashcards. Because I have a flashcard memory that says, oh, that's right. If a function has a horizontal asymptote, then the limit as that function approaches infinity equals the value of the asymptote. That's my flashcard. And so if you have that same flashcard, when you read this, that memory will come to mind. And so on the flashcard, I would literally have something like what I just said, you know. So this function has a horizontal asymptote at y equal 2. Therefore, so it's like one side of the flashcard is going to say, if a function has a horizontal asymptote at y equal 2, and I go dot, 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 and I flip the flashcard over, the backside says, then the limit as x approaches infinity of that function has to equal 2. And one of your most commonly used tools in any math problem is trying to set up some sort of equation and then use that equation to solve for some unknown. So in this case, we're hoping to be able to figure out the value of A or C or something, but I'm not sure even why this will help. But I know this to be true, so that's where I start.
Okay.
Cool, I'll just keep going then. My next thought is, okay, I'm looking at a limit problem, so my brain has a flashcard that says, oh, when I'm solving a limit problem, first thing I look for is x approaching infinity. It is. So then I look at terms that I can compare that are being added. So I can make some comparisons and create a new limit problem. So it works better if you talk more than I do. So Preston or Ashley, when you see this, you remember that as x approaches infinity, we can compare terms they're adding. What new simplified limit problem can I create here?
Well, could you like plug in infinity for like x?
You essentially are mentally.
Yeah.
Yeah, it's not really, you know, because infinity is more like, it's not like a number, it's more like the idea that x just keeps getting bigger and bigger. But that's the idea.
So it just be b over just
And then b, well, if you plug, like b is, my brother was saying like b is smaller and 3 is smaller, so you kind of just like ignore that.
The idea is that this is going to keep growing forever. So as this gets larger and larger, multiplied by a, this will get larger and larger. Then we're just adding something, but compared, yes, this will dominate, this will dominate. So the new limit problem you create looks like this. And again, don't forget that you have to still maintain your equality. So it gets me to there. So then I say, okay, now it's getting pretty easy to see. Because I can write these separately as two fractions being multiplied.
What made you do a over 1 and x over x?
I want to isolate this because this is one of those special fractions. Like, what value does this fraction have, Preston? 1. It does not matter how large x becomes, this fraction will always equal 1. So as x gets really, really large, what's this going to equal, Preston?
A times 1.
Which
A over
is a.
Yeah.
So the limit of this function as x gets large is just a, but we declared at the very beginning that the limit of this function had to be 2. so we were able to figure out that A must be 2.
Okay, that makes sense. Should we just do the same thing with C?
When you say the same thing, what do you mean by the same thing?
Kind of, well, I don't know. What do you do when the x approaches? So when you do the horizontal asymptote, it's x approaches infinity, but the vertical asymptote is similar, or?
No, so that's where you need another flashcard.
Isn't that like the bottom you plug in -3 for x?
Yeah, so you need a flashcard that says something like this. Let's see. The vertical asymptote occurs at a value of x, and dot, 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 flip the card over, which causes denominator to equal 0, but numerator to not equal 0. That needs to be embedded in your memory so that when you read this problem, you think of that, like Ashley was doing. You think, oh, okay, vertical asymptote means I take the numerator, plug in the x value, denominator, plug in the x value. I want the top to end up being not 0, but I want the bottom to equal 0. Well, the top seems pretty straightforward because I just got this plus this, that's going to be some number. But if I choose C to equal exactly +3, then I get the vertical asymptote to occur where they want the vertical asymptote to occur. Then A plus C is 5.
Yep. I just need to remember the concepts. Because I could have gotten that if I didn't know all this.
Yeah, you're just slipping back into the old habit of thinking that you succeed by memorizing problems and then just redoing them.
I know I am.
Yeah, you can't. So.
I hate it. I don't want to do that because I know that I'm going to fail this class if I do.
Well said. Your turn, Ashley. Which one do you want to talk about?
Can we do